Hi, in this video I'm going to show how to step through a log file message by message. So right now I'm in master. I'm going to move the keyboard away from the computer. I create a new branch. Okay, so for post-processing I'll make a new package so that all the post-processing is separated from other topics. So I will make a new class which will then be able to listen to the events in the log file. So an event refers to any kind of message that was recorded during the operation. So event equals message. Let's give it a name. This may be a new trajectory process, and we can add it now or later. We need an offline log listener. All that does, if you add it here, it will create this appendix and also already provide to you the function that this interface requires. So we can use F3 to navigate into this class. It's not commented yet what this function is supposed to do. Basically, a function processes message from a log file. And so now I'm back to new trajectory process. I'll make a main function which allows us to already run this class. And the process, let's see if I can find a log player. Yeah, it's the offline log player. It allows me to specify a file, which is the log file, and then the offline log listener, it is precisely what we are designing inside the class. So first I need to define the log file, which is user home. I hope that's correct. And then go-kart pursuit. And for the rest I have to check. That's here. .cm. Let's check. Yeah. So that's the log file, and this function requires one or more offline log listeners. One of them, we'll instantiate this class and then provide it as an offline log listener. So I'll specify this to be an offline log listener. New trajectory process, so I'm done here, and then the name of the variable. So the reason why there is an arrow is that this function call may fail because, for instance, the file may not exist, or yeah, that's actually the only reason. So I'll press Control 1, which gives me several options to deal with this problem. And I'm going to choose the first one, add throws exception, because this delegates the problem to the outside world, so I don't have to delegate. I don't have to deal with the problem here. So if I run this, it takes a while, but which means it goes through all the events, but it essentially doesn't do anything because this function doesn't do anything. So now what we can do is we can print here, we can print the time of the message and the channel, and already run this. So so basically this already is an example of a simple log file log processing. You can see whether, what kind of messages are there and how frequent they appear. And in this demo, we could, for instance, listen to a certain type of message. So, and every message is identified by the channel name. Let's suppose we use the go-kart channels, go-kart status get as a criteria. So I can insert a if criteria. So if channel equals to go-kart status get, then print the time, and perhaps byte buffer dot available or remaining, let's run this with Control F11, and so this shows us fewer messages, which only from this channel, and the number of bytes we can, which are contained in this message. Now, if we want to recreate the message itself, we really have to go on a case-by-case basis. So go-kart status channel get contains messages of the type go-kart status event, and let's see what this class provides. So here's a constructor which takes the byte buffer as an argument, and then it will read the 4 bytes, which is the float, and create this steer column encoder. So the only purpose of this message, go-kart status event, is to encode the steering column absolute position. So to complete this example, I will use this constructor to create the message that was available, that was in the go-kart software at the time of the go-kart, when the go-kart was operated. So I'm going to use that constructor just by just like that, and now I have that status event as an object available, and I can use functions from that class. So instead of printing the bytes of the message, I'll just print the steering column value, which, by the way, this is not commented here because that itself is go-kart status event implements an interface which provides the functionality of get steer column encoder centered, for instance, or is calibrated. So these are essentially the functions that we have available. For instance, I can restrict myself to this interface, and I can say, okay, I just want to treat the message as a steer column interface, and instead of having this go-kart status event, which so it's kind of restricting ourselves to what only what we need. So now I run it again. And so we see here, this is the angle of the steering encoder. The reason why this is not exactly like in degree or radians is because it's actually a unit provided by the steering column itself. So if you want to extend the example, you basically can extend the list of messages you are treating in this function, and you can check for other channel names and create messages using the respective class. So I think that's all for now. I can maybe review the changes and commit that. So it's just these two. Oh, I made a comment in the offline log listener, so and then I'm gonna commit these. So am I in the right branch? So I'm gonna make video demo of logfile processing. So again, let me know if you have any questions. I'll commit